Okay, so we're going to talk about angle of elevation and angle of depression. Now, we did talk about this a little bit last year, so I just kind of want to quickly review. Remember that angle of elevation, we start with a horizontal line. And angle of elevation, think about when your eyes get elevated, when they elevate, we will look up. So there is your angle of elevation. Now, one thing you also need to try to remember is that angle of depression will start up here and come down like this. So the angle of elevation and the angle of depression are alternate interior angles. So they are congruent. So whenever we're going to be dealing with any kind of a word problem, we will be dealing usually with a right triangle, not always, but for the most part, yes. And so when they refer to the angle of depression, if they refer to the angle of depression, just recall that it is equivalent to the angle of elevation. So we're always going to put that angle of depression down here inside the triangle so that it makes it a little bit easier for us to solve. Okay, so let's look at this problem. A man at one point on the street. So let's see, we have a man right over here, and he finds that the angle of elevation of the top of a tower is 29 degrees 50 minutes. So here would be the ground, here would be his tower, okay, and the angle of elevation would be 29 degrees 50 minutes. Then what he does is he starts walking horizontally to a certain point, and this distance they give us is 200 feet. Then he finds at the second point the angle of elevation is 65 degrees 20 minutes. So this angle of elevation, we have a second one, is 65 degrees 20 minutes. What is the height of the tower to the nearest foot? So obviously that's the height of the tower. Now we did this last week. What you have essentially, well, we do have three triangles, but we have two triangles that are side by side. And if you recall, the way that we solved these was to actually find the side that's shared by the two triangles that are side by side. So we're going to actually try to find y first, because we have this side down here that's 200. So we're going to do law of sines here. So we're going to use that side y and the angle opposite it, and then 200 and the angle opposite it, which will be this one. So now you have to recall that in order for us to find this angle up here in the corner, we need to remember that this 65 degrees 20 minutes and this angle down here on the bottom left-hand corner in green that I'm just dotting are supplementary. So you're going to take your calculator and you're going to do 180 degrees minus 65 degrees 20 minutes. Now remember to use your second apps button. So you're going to do 180 minus 65, hit your second apps. You'll see at 1 is your degree symbol, hit that, and then type in 20, do second apps again. Go down to number 2, there's your minute symbol, and then hit enter. Okay? Now, that's going to give you a decimal equivalent, and we don't want that. So what you're going to do is hit your second apps button one more time, and go down to number 4 where it says DMS. Hit that, hit enter, and then that angle that is in green that I have down there is 114 degrees, 40 minutes. Then what you'll continue to do is find all the other angles in the triangle on the left and the triangle on the right. Okay? All right, so here is our picture without all the little fun tower pictures and all of that. So as I said to you in the last slide, we have this is 114 degrees, 40 minutes. The one up here should be 35 degrees and 30 minutes. I know that's squeezing in there, that's 30 minutes. And then this one over here, I can't fit that in, so that is 24 degrees, 40 minutes. All right, so again, if you recall, what we're going to do is we're going to find the side that's shared by both triangles on the left and the right. So we're going to find y. So we're going to do law of sines. So we're going to do 200 over the sine of 35 degrees, 30 minutes, and we're going to set that equal to y over the sine of 29 degrees, 50 minutes. And do a little bit of cross multiplication, and essentially what we're going to do is 200 times the sine of 29 degrees, 50 minutes, and we're going to divide that by the sine of 35 degrees, 30 minutes, because what we'll be doing is cross multiplying to solve for y. Now you're going to put that all into your calculator, and you should get a decimal value of 171.3367, and then it does keep on going. Don't erase that from your calculator. I'm just going out 4 places so that you can see what that is. Okay, so here we go, and if you recall, we had y equal to 171.3367. Now what we're going to do is we're going to use the triangle on the right-hand side, and we're going to solve for x. So we're going to do law of sines one more time. So we're going to go x over the sine of 65 degrees, 20 minutes, and we're going to set that equal to y, which is our 171.3367, blah, 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 over the sine of 90. Now, if you remember, the sine of 90 is 1. So really, when we end up cross-multiplying x times the sine of 90, that's just going to give us x. So really, x is just going to be 171.3367, and we're going to be multiplying that by the sine of 65 degrees, 20 minutes. Throw that into your calculator. You should end up with 155.7024, and the answer asked to round to the nearest foot. So that would be 156 feet. Okay, there you go.